After the test on Wednesday and Tuesday of this week, depending on what block you're in, you were supposed to pick up a note sheet. You will notice that the first slide of this video is not one of the note sheets that I gave you. The reason why is this is all vocabulary. So if there are certain things on this current slide that you do not remember from middle school, you need to copy them down and you need to write them somewhere in your notebook. So the first three things up here are names for classifying triangles by the number or lengths of their sides. All triangles have three sides. If there are no congruent sides in the triangle, it is called scalene. If there are two congruent sides in the triangle, it is called isosceles. And if there are three congruent sides in the triangle, it is called equilateral. The bottom four classifications are classifying the triangles by the measures of their interior angles. If every angle inside the triangle is acute, remember acute means under 90 degrees, that is called an acute triangle. If the triangle has one right angle in it, it is called a right triangle. If the triangle has one obtuse angle, remember obtuse means greater than 90 degrees, it is called an obtuse triangle. And if the triangle has all three angles congruent, it is called equiangular. Equiangular triangles, since all three angles are the same, each angle would have to be 60 degrees because all of the angles inside of a triangle must add to 180 degrees. So if each angle has to be the same, each one would have to be 60 degrees. The next slide of this is the first slide that you have. The first question says, classify the triangle by its sides, then determine if the triangle is a right triangle. In order to classify the triangle by its sides, you need to know the length of all three sides. When you're in a coordinate plane like this, the way you find the length of each side is by using distance formula. If you don't remember distance formula, it is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we are going to have to use distance formula 3 times since there are 3 sides in this triangle. So I'm going to start by doing the first side, and I'm going to find the length from P to Q. So the length of PQ would be written as -1 minus 6 squared 2 minus 3 squared. Underneath that square root, subtracting the first two numbers and squaring would give me a value of positive 49. Subtracting the second two values and squaring would give me a value of positive 1. Because remember, anytime you square a number, whether it's positive or negative, the answer will always come out as a positive value. If I add those numbers together, I get a total of 50. And if I want to write that as a decimal rounded to the nearest tenth, that decimal would be 7.1. So that side length from P to Q has a length of 7.1. The next side length I'm going to find is between O and Q. And we will do the exact same thing we just did, but with different coordinate points. So I will do 6 minus 0 squared, 3 minus 0 squared. In each one of those, 6 minus 0 is 6. Square that, you get 36. 3 minus 0 is 3. Square that, you get 9. Adding those together gives me a 45 underneath my square root. And if I round that to the nearest tenth, the square root of 45 comes out as 6.7. The last side length I'll find is between P and O, and I'm going to find that the exact same way. So between P and O, we would do 0 minus -1 squared. We would do 0 minus 2 squared. For each of those values, 0 minus -1 is 1. Square that, you get 1. 0 minus 2 is -2. Square that, you get 4, which gives me a total of square root of 5. If I want that rounded to the nearest tenth, it would come out as 2.2. After having found all three side lengths, we would come to the determination that all of the lengths are different, which means this is a scalene triangle. If two of the lengths had come out the same, we would say that it was isosceles. If all three lengths had come out the same, we would have said it was equilateral. The last thing this question asks us is the triangle a right triangle? So by looking at the triangle, what we're going to do is identify which angle we think may be the right angle. In my opinion, the right angle would probably be here at O. In order to determine if that is a right angle, we need to know the slopes of each one of those side lengths. If we know the slopes of those side lengths, we can compare those with what we learned about perpendicular lines. So if we find the slope of PO and we find the slope of OQ and they are opposite reciprocal, then we know that they would meet at a right angle, and triangle PQO would be a right triangle. So if we find the slope of PO, I would count down 2 and right 1. So PO slope would be -2 over 1. If I go from O to Q, I would go up 1, 2, 3, and I would go to the right 1, 2, 3, 4, 5, 6. So OQ would be up 3 and right 6, which would be a reduced slope of 1/2. If you look at the two slopes, one of them is -2, one of them is 1/2. They are opposite reciprocals, which means yes, this triangle is a right triangle. And the reason, again, is because that angle at O is a right angle because their slopes came out in opposite reciprocal form. In the next problem, it is the exact same thing, so you have an extra problem to use as practice. If you would like to see the worked out solution, that is posted on my website with the worked out note sheet. So feel free to work that problem out as an extra example if you feel you need one, and then you can verify that you did the problem correctly when you check my website. The next things that are on this note sheet are a few of the theorems that we're going to talk about for today. So the first thing we need to talk about is what an interior angle is for a triangle. As you notice in this picture, the interior angles are marked along the inside of the triangle. That's why they're called interior. And what we're going to learn below is that the interior angles of any triangle always add up to 180 degrees. Does not matter what the classification of the triangle is, the angles always add to 180. The next picture to the right-hand side are the exterior angles of a triangle. Notice all of these angles are on the exterior of the triangle. The exterior theorem that we're going to talk about involves an extension on the outside of the triangle, in this case angle 1. That measurement is equal to the far angles added together of the triangle. They're called the remote interior angles. So angle 1 on the outside is equal to the other two across the triangle added together. For example, if I told you that angle A was 60 degrees and I told you that angle B was 80 degrees, angle 1 could be found by adding 60 and 80 together to get a total of 140. That is just a specific example of that theorem. The last thing on the bottom down here is an extension to the triangle sum theorem. That theorem says if you know that the triangle is a right triangle, angle C would be a 90-degree angle. Since all of the angles in a triangle add to 180, what that tells you is angles A and B have to add to 90 degrees because angle C has already used up 90 of the 180 total. So that's what this theorem tells you. If you have a right triangle, the two small angles have to be 90 together. So if I know that triangle ABC is a right triangle, if I tell you that angle A is 40 degrees, then you would know then that angle B would have to be 50 because B and A have to add together to be 90 if angle C is already a 90-degree angle. The next part of this is on the back, and it is just a lot of different problems using the triangle sum theorems, whether they're the interior angles or the exterior angles. So in the first problem, it says the measure of each interior angle is given as x, 2x, and 3x. What we know about the interior angles of a triangle is that the three of these have to add together to be 180. So all we're going to do is write an equation that says that. Those three angles added together are 180 degrees. Your job then is to solve that equation. Combining like terms gives you 6x equals 180, and that means that your x value is 30 degrees because you would divide both sides by 6. Now the directions of the problem say that you want to find the measure of each angle, not just the value of x, which means that we now need to go back and plug that 30 in for each one of the angles. The measure of angle A was simply x. That's why A is 30 degrees. The measure of B is 2x, so 2 times 30 would give us 60 degrees. The measure of angle C was 3x, so 3 times 30 would give us 90 degrees. So this triangle is actually a right triangle. In the next problems below, again, it's just using the interior and exterior angle theorems. In this next one, this is a right triangle, which means that the two small angles, according to the corollary on the last slide that we talked about, those two angles would have to sum to be 90 degrees. So writing the appropriate equation and then solving it. 3x minus 6 equals 90. Adding 6 to both sides gives us 96. Dividing both sides by 3 gives us 32. The confusing theorem in this lesson is usually for students the exterior angles theorem. So on the exterior out here, this 2x minus 5, that angle is always going to be equal to the two far angles in the triangle added together. So your equation, 2x minus 5, that's the exterior angle, should be equal to the other two added together, x plus 70. Solving this equation involves a couple of steps. We would add 5 to both sides, and we can also subtract x from both sides. Doing both those things gives us a result of x equals 75. The next few problems, again, are all the same type of problem. So I'm just going to work these out, and you can follow along as I work them out. I'm going to add x, 2x minus 3, 3x minus 15. Those should give me 180. Combining like terms, 6x minus 18 equals 180. Adding 180 to both sides gives me 6x equals 198. And then the last step for the problem would be to divide 198 and 6, and you get a value of 33. In the next problem, it is an exterior angles problem again. So this exterior angle would be equal to the two on the other side of the triangle added together. So 5x minus 10 equals 3x plus 40. Combining like terms and getting all your stuff switched around, I'd add 10 to both sides. I would also subtract 3x from both sides. Your new equation would say 2x equals 50. And that means that x would be 25 after you've divided both sides by 2. Moving down, last problem here. The first thing that I would do is figure out what I need to find first. The value I need to find first is going to be x. Even though the problem says find y, I have to find x, and the reason why is because if you look at the picture, there are a lot of angles in this picture with x in them. So finding x is going to be the only thing that you can do. So I'm going to write my equation using exterior angles theorem. And that is the exterior angle is equal to the two on the other side of the triangle added together. So if I combine my like terms after I've written my equation, this is what my equation looks like. I would do a couple of things to rearrange here. One of the things would be to add 47. One of them would be to subtract 3x. And I would get an equation that says x equals 43. Now, if you look at your answer choices, you have to be careful here. This is a very ACT type problem. Notice that 43 is one of the answer choices. However, it is not the correct answer choice because the problem is asking us to find the value of y, and this, 43, is the value of x. So I need to take that value, plug it in, and help me figure out the value of y. The place I'm going to plug this in at is in each one of these corners. So I'm going to plug in the value there. So 2 times 47, subtract 4. And then that one is just 47 because, oh, I'm sorry, it should be 43s, not 47s. Let me erase that real quick. So it would be 2 times 43 minus 4. And then that one right there would also be 43. So that bottom angle, if you multiply 2 times 43, you get 86. Subtracting 4 would give me 82. And you've also got 43 down here in the corner. Now, why is that important that I do that? Because this 82 is an angle inside the triangle. The 43 is inside the triangle. The 2y is inside the triangle. So I can use the interior angles of a triangle theorem to figure out the value of y. So I'm going to take those angles, 2y, 82, and 43. I'm going to add them together, and I should get 180 because they're inside of a triangle. Combining my like terms, 82 and 43 are 125 together. In order to solve for y, you would subtract 125 from both sides. So 2y equals 55. And you would divide both sides by 2 to get 27.5. If you have any questions about this lesson, make sure that you make note of them so that you can ask in class next class.